In this video, we're going to talk about supplemental examples from 7.2. Let's go ahead and get started. These will all be on the disk washer method. So write and evaluate the definite integral that represents the volume of the solid formed by revolving the region about the y-axis. So our rectangle here, as we've drawn it, is perpendicular to our axis of rotation. So we're going to be using pi r of y squared dy, and we're going to go from C to D there. So this is 1 to 4 on the y-axis. We have negative y squared plus 4y quantity squared dy. This is pi integral 1 to 4 of y to the fourth, and that's negative 4y to the third, and another negative 4y to the third is a negative 8y to the third. 4 times 4 is 16. Y times y is y squared. dy is going to be pi times, and this is going to be y to the fifth over 5 minus 2y to the fourth plus 16 thirds y to the third from 1 to 4. Let's just check all that again. Negative 8 divided by 4 is negative 2. That's right. So I'm just going to show you how to more easily do this in your calculator. To evaluate the fractions, instead of typing everything in twice, we can go to x fifth over 5 minus 2x to the fourth plus 16x to the third. Oops. $16x to the third divided by 3. All right, x to the fifth divided by 5 minus 2x to the fourth. 16x to the third divided by 3. Awesome. So I'm going to go into vars, y vars function, y1 of 4 minus, and then vars, y vars function, y1 of 1. That function notation, I get that that is 30.6 pi, which is the same thing as 153 pi over 5. If you want to go ahead and plug in the 4s here and simplify, and plug in the 1s here and simplify, you should get the same thing. Let's find the volumes of the solids generated by revolving the region, bounded by the graphs of the equations of the given lines. So we have A, have a y-intercept of 4, a vertex at negative b over 2a. It's going to be at x equals 2. At x equals 2, we have 8 minus 4 is 4. B over 2 times negative 1 is negative 1. Negative 2 over negative 2 is a positive 1. So let's try that again. 6 minus 1 is 5. 1, 5. Then we have like so. It's going to come down like so. This is going to come down. 3. It's going to come through there. 1. So 3, 1. And it's 4 over here. All right. So our points of intersection are 0, 4, and 3, 1. And I'm interested in this region here. It's going to be revolved about this axis. So making rectangles that are perpendicular to our axis of rotation. We're going to have 0 to 3 of our function is the parabola. Minus lower function is the line, like that. This is 16 plus 8x minus 4x squared plus another 8x plus 4x squared minus 2x cubed minus 4x squared minus 2x cubed plus x to the fourth. Then we have minus 16 minus 8x plus x squared dx. Pi 0 to 3. 16 minus 16 is 0. 8x and 8x is 16x plus another 8x is 24x. Then I have a negative 4 and a positive 4 is 0x squared. And a negative 4 and a negative 1 is a negative 5 squared. And then I have minus 2 and minus 2. Is a negative 4x cubed. And then plus x to the fourth dx, like that. This is pi times, and this is going to be 12x squared minus 5/3 x cubed minus x to the fourth plus 1/5 x to the fifth. Evaluate that from 0 to 3. Same thing as before. So let's make this now 12x squared minus 5/3 x to the third minus x to the fourth plus 1/5 x to the fifth. And y1 at 3 minus y1 at 0. I get 30.6 again. Interesting. which is the same thing that I got up here. So that should be 153 pi over 5. Yes. Okay. Now for part B, that was all part A. Part B, we want to revolve around the line y equals 1. So I have pi equals 0 to 3 of 4 plus 2x minus x squared minus 1, because that's what I'm revolving around. That's my distance to that line. And that's squared minus 4 minus x minus 1, quantity squared, dx, pi 0 to 3 of 3 plus 2x minus x squared squared minus 3 minus x squared dx is going to be pi 0 to 3 of 9 plus 6x minus 3x squared plus 6x plus 4x squared minus 2x cubed minus 3x squared minus 2x cubed plus x to the 4th. That first part, minus 9 minus 6x plus x squared dx. So 9 minus 9, and then 6 and 6 is 12, and another 6 is 18. And then negative 6 minus 1 is a negative 7. And then plus 4 is a negative 3. All right. Now I have a negative 2, and a negative 2 is a negative 4x cubed plus x to the 4th dx. So that's 9x squared minus x cubed minus x to the 4th plus x to the 5th over 5, 0 to 3. Go back to my calculator here. So that's going to be 9x squared minus x to the 3rd minus x to the 4th plus x to the 5th divided by 5. And we still want the same x values from 0 to 3. So that is 21.6 pi, which is equal to 108 pi over 5. All right, one more problem here. We're going to find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the x-axis. So we have y equals e to the x over 4. It's rising like that, goes through 0, 1, goes through 6, 6, and then e to the 3 halves up there. X equals 0 and x equals 6. So we're looking at this region right here. We're revolving about the x-axis here. So our rectangles are going to be vertical so that they're perpendicular to the axis of rotation. And so we have integral from 0 to 6, pi on the outside, r squared dx, like that. It's pi 0 to 6, e to the 2x over 4, dx is pi 0 to 6, e to the x over 2 dx. Going to have to multiply by 1/2 on the inside and 2 on the outside. And that gives me 2 pi e to the x over 2, evaluated from 0 to 6, is 2 pi times e cubed. 6 divided by 2 is 3, minus e to the 0 is 2x e to the 3rd minus 2 pi. So let's approximate that here. 2 pi e to the 3rd minus 2 pi is going to be about 119.92. All of these volumes should be in cubic units. Make sure that I did that on all these examples. Didn't do it on any of the examples. So there you go. Make sure you're answering in cubic units. If you're given units of feet, inches, whatever, answer in an appropriate unit there with cubic centimeters, cubic inches, cubic feet, whatever. All right, that's it for this video. We'll come back next time and talk about supplemental examples from 7.3. See you for the next video.